everybody. It's MoNaCo here.
And Milks.
Unit 4, Chemical Bonding, third homework video, page 7, C8.
Yeah, today we're going to learn how to draw Lewis dot structures specifically for ionic compounds.
Yep. There's a different method for covalence, and we're going to cover the ionics first.
Yep, ionics first, covalence later, and we'll get there. Okay, so
you got to remember this thing, and you actually taught me this a couple of years ago, Mr. Milks. I appreciate it. A, B, C, D. I know it's the first four letters of the alphabet, but it stands for something special here.
Right, so the A is going to stand for atoms. We need to include atoms whenever we draw a Lewis dot structure for ionics. We're going to write the element symbols, and in this case, NaCl. Those letters telling me sodium and chlorine are there.
Those letters represent both the protons and neutrons in the nucleus as well as the kernel electrons.
Okay,
that's true.
Yeah, it is very detailed.
B for brackets. Brackets show that we have this kernel of an atom, but something's happened to it. So put brackets around the symbols before and after. So you have your symbol Na, bracket on both sides, Cl, bracket on both sides. We mean brackets, not parentheses. Parentheses are for some different notation. These are for brackets.
Right. I like to think of the brackets as the walls where the ion says, my electrons, you cannot have them.
Right. I'm stable with this many as it is.
Right.
Don't touch. Hands off.
And it's the differentiation between what we learned when we did the basics of covalent and ionic, where the covalent share, but the ionics had that complete transfer. The chlorine atom literally took the sodium's electron, and he's not giving it back. So we put up those walls.
And yeah, so we put the brackets around it to show that it's an ion, because outside of the bracket, we put the charges for the ion. So the plus on sodium here shows that it has lost one electron. And the minus on the chlorine there shows that it has gained one electron. So the brackets signify that an ion is in play, not an atom.
Right, and what's key, but it maybe doesn't show, is that these ions form first.
Right.
And then the charge of the positive and negative stick together like magnets.
Pulls the two together. And so the last thing is the dots, because these are dot structures after all.
Right, and we know the dots represent
valence electrons.
Valence electrons. We did that last unit.
Mm-hmm.
And we'll see here where the metals will never really ever have dots.
Because their valence ring is now empty.
They lose them all.
Because metals are losers. They have low electronegativity, low ionization energy. It's why they conduct electricity and heat very well, because they are very free with their electrons. Hey, you're a non-metal, have an electron.
Here you
Easy goes. I feel like I want to be positive anyway.
Right, there you go. So now we're going to have to do some examples quick.
Yay, we get to draw.
Yay, on the board.
So we're going to combine sodium and fluorine. Mr. Milks will take the first one.
All right, so I'm going to start with the actual
atoms,
Na and Cl.
F. So starting with the atoms, A, atoms, you drew the symbols. Now B, brackets. You draw some brackets. I need to put in the charges that are going to form. So I would take that electron.
Right, so this one electron from sodium is going to come all the way over there.
And fill in that gap on fluorine.
Right? Oh, no, it's on the bottom. Sorry. And so it's going to have a +1 charge
for sodium.
And fluorine's going to get a -1 charge.
So we've got our atom symbols, our brackets showing their ions, our charges. Now we got to put in our
dots. So I'm going to do the 7 fluorine dots in green that the fluorine had.
Right.
And then that one dot for now that came from sodium, I'm going to fill him in blue just to help us see where he kind of came from.
So yeah, it sees where it came from. Okay, cool. So you're giving me the tough one, Milks. You're giving me the one that's got 3 elements involved?
I'll do 4 with 4.
Oh, all right. I think it still goes by the same rules. Atoms, brackets, charges, dots. Cool. I'm going to first decide where my electrons are coming from and going to. Magnesium's got 2. It's a metal, so it's a loser.
Metals lose.
Each one of these fluorines has 7. They want 8. They're non-metals. They're winners. So I can't give 2 electrons to one fluorine. I have to split them up, don't I?
1 to each, looks
One
like,
to
right?
each. So I'm going to take that one electron and give it to that fluorine. And going to take the other one and give it to that. Complete transfer. We've got ourselves a transfer, so that's ionic. So I'm going to start by writing my atoms. Mg. Okay. And then I'm also going to put F's out there. Let's see, one goes to each element, so we're going to make a sandwich. Why not, right? So I'm going to put F for both of these. Realistically, you can draw these anywhere, anyhow, but it's nice and neat if we draw it together.
So there's
atoms.
So there's your A for atoms. Now you need B for brackets.
B for brackets. So everybody gets a bracket. I'm going to use black for brackets.
Ooh, they both start with B.
B for black brackets.
All right.
Charges. ABC charges. So charges for magnesium. So magnesium had 2 electrons. It lost 2. So the number is going to be 2. So it's got to be a positive 2 for magnesium. So positive 2 for magnesium. Each fluorine gained 1. So each one is going to have a negative 1 in the corner.
Nice. A, B, C.
Now we got to do our dots. So our dots, magnesium's valence shell is now empty. It doesn't get any dots. It's a metal. The fluorines each started with 7, which I'll put in blue. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I'll put in green the 1 electron apiece that came from the magnesium. So now we've got atoms, brackets, charges, and dots. Boom! Mr. Milks, take that.
Got it. Well, let me see if I can do the same thing here. So I'm going to start with where my electrons are going to go. Again, I'm dealing with fluorine, and I see that fluorine each needs 1, and my aluminum has 3 to give. So again, I can give 1 to each. So this one's going to go here. This one's going to go here, and that one's going to go down there.
Full transfer.
Full transfer. Aluminum's going to lose all 3 of his electrons.
Atoms, brackets, charges, dots.
All right, so atoms first. I'm going to kind of make a sandwich, but I have 3 sides for my Al, so I'm going to do Al, and I'm going to do fluorine on either side, and I'm going to do 1 underneath.
Atoms, got it.
Got
What's
it.
next?
Brackets.
Black brackets.
Let's give everybody a bracket. Okay, after B, I got C as charges. So let's start with aluminum. Aluminum lost 3 electrons.
So now it has 3 more protons than electrons.
Right. So I like to think about it this way. Ready? If I had, let's go backwards.
Yeah, don't go back.
Yeah, let's go forwards. So if I lose 3, I have 3 more protons. I have a plus 3 charge.
All metals are positively charged ions anyways when you look at the periodic table. So
now the trick here is that each fluorine only gets 1. So each fluorine is going to be a negative 1 charge. And one thing we haven't mentioned yet, if we try to total these charges up,
negative 1 plus 3 is positive 2, minus 1 is positive 1, minus 1 is 0.
Perfect.
Got it.
That's what we're actually looking for. So
Overall
these numbers
charge
should take an
add up to
overall
0.
charge to 0. So that's just a little check for ourselves, okay? Now, aluminum's not going to have any valence electrons anymore, our dots.
No dots.
So we're going to put some on fluorine. So let me give each fluorine is 7.
That it started with in green.
We had these to begin with.
Got it.
And then for you guys at home, if you don't have different colors,
And X's too, can't you?
yes, I'm gonna do that. I'm gonna use it in red so you can see it, but I'm gonna put an X this time for the electron that came from aluminum, just in case you're stuck doing one color at home and you got a different way to see
For sure.
how you can.
Heck, you could use triangles or squares or whatever you
could.
got to do because it's all about the, the key to the map. So to
Right,
speak.
you need the right number. That's the most important.
And the right location.
True.
And you need the right letters: atoms, brackets, charges, dots.
Right. You need all those things. But if you put all the dots around the aluminum, that's not correct. You're
No.
right. So they need to be in the right spot.
So there we have it, the aluminum fluoride, trifluoride, or something like that. We'll cover the names of these things in the next video.
There you go.
Yeah, so we don't have to worry about naming them yet. We just have to worry about doing the atoms, brackets, charges, and dots.
There you go.
ABCD.
That's it. Atoms, brackets, charges, dots for ionic
Bonding
compounds.
only. Yeah.
Yes, just for ionics.
I guess the one thing that we were doing first, we were circling and showing where the electrons went from and to. So that's not part of the ABCD process, but it certainly helps organize your thoughts
Yeah, that's really just for the teaching piece. So
before you're doing the drawing.
so we know what's going on. Yep.
So thanks for watching. Have a good one. Next video, naming these ionic compounds.